Today's topic is about multiple linear regression analysis problems and by using Excel also. So in our earlier videos, we had already discussed about what is regression and correlation and what are the kinds of regression analysis we have, and simple linear regression also we had already finished in our previous videos. And today, I'm again going to explain about what is multiple linear regression and problems by using Excel also, how we can solve. Let us see. So, what is regression means? In our earlier classes also, we had already known that it is a statistical technique. It analyzes the relationship between two or more variables, and we can use that information to estimate the value of the dependent variables. So the main objective of this multiple regression is to develop a model that describes a dependent variable to more than one independent variables. In our earlier classes also, I had already explained one example about the dependent variable of salary, and independent variables are like age of that person and his educational level and the working hours he worked. So these are all the independent variables, and the salary is the dependent variable. So for one dependent variable, there are one or two or more independent variables. Then we can say it as a multiple linear regression analysis. So that is the meaning of multiple linear regression. There is a relationship between two or more variables. So we can use this to determine how one variable is affected by changes in another variable. For example, uh, price, the commodity price, the price of a product, and the changes in buying behaviors of a customer. Because of price increase or price decrease, the customer buying behavior may change. So those changes, those characteristics, we can consider it as independent variables, and the price changes, we can say it as a dependent variables. So like that, we can estimate and we can predict the buying behavior of the customers when the prices are changing. So this regression analysis, it helps to identify the strength and the direction of the relationship between the dependent variable and independent variable. So by using this regression analysis, we can find the best fit line that can predict the value of the dependent variable. For example, we can consider in a hospital, patients are waiting for the doctor visiting. So means the patient is a dependent variable and he is waiting for doctor or for some other thing we don't know. So there will be some predictions. Those are all the independent variables. The patient is the dependent variable, and we can predict and we can estimate the best independent variables for that dependent variables. So this is about regression, and in the multiple regression we are following one or two or more variables for the dependent variable. So in the linear regression, we had already discussed one dependent variable and one independent variable. Only one variables only will be there in both sides. In multiple regression, we can consider as two or more variables will be there in the independent variables. So in previous classes, we had already seen about linear regression, and again this class we will see some of the problems and examples by using Excel also for the multiple regression. And the correlation also, we need the correlation problems, the R square and the standard deviation also values also we need for to do the multiple regression analysis. So we should be thorough about correlation coefficient in earlier only while doing this regression analysis. So the regression lines for the both dependent and independent variables of x comma y are regression line of y on x, that is y equal to mx plus c. Regression line of x on y equal to x equal to my plus c. Here we can see the graphs. This is x-axis, this is y, and this y is the dependent variable, x is the independent variables. For example, we can say So the line it is going means it's a going negatively. So, it's going both x side and y side, it's increasing. So it's going positively. So the r value will be plus 1. And then the next linear graph, you can see the dependent variable and the independent variables. Both values are in coincidence. So there is a 90-degree variation between that. So the R value will be 0. And when it is a negative correlation means we can see that the graph will be like this. And for the high degree of correlation, the values, the intersecting values will be like this for the both x and y by following the mean values. And for the low degree correlation is vice versa to high degree of correlation. So like this, we need to use these intercept values and the mean values from the correlation graph also for to do the regression analysis. And the regression equation is like this. Two variables of x comma y. Y is the dependent and x is the independent variables. And the y-axis and x-axis, y equal to mx plus c and x equal to my plus c. And the slope value will be is here, and then the intercept value will be denoted here, intercept c. So this is the equation for the both variables. And the regression equation is y minus y bar equal to r standard deviation of y by standard deviation of x into x minus x bar. So this is the regression equation. And for this, we need to find out all the standard deviation and r values and mean values to do the regression equation. R means correlation coefficient, and these are the y bar and x bar are the mean values of x comma y, and standard deviation of y and x values. And we can find out the regression coefficient by r equal to standard deviation of y by standard deviation of x. So this is the regression equation. So for the example of multiple regression, we can see. So this regression, it allows us the researchers to predict and explain the variation in one variable based on another variable. So scientists, they might use different amounts of fertilizers and water and different fields. So on different fields, those are all the independent variables. Fertilizers are dependent variables. So and they can see how it affects on crop fields. So this is the one of the example for multiple regression analysis. So in linear regression and what is multiple regression differences, earlier videos also we had already seen, that only recap I'm doing. And when to use this multiple regression analysis also we had already discussed. And let us see some of the problems for the calculation of regression analysis. So we know the formula for multiple regression analysis, that is equal to, we need to predict the all variables by using y equal to b0 plus b1 into x plus b1 plus b2 into x2 plus like this. So we need to add the values of those x1 values, those x1, x2 and these xp values are the independent variables. So y is the dependent variable. We need to multiply the values, the independent variable values with the b1 plus and the all independent variable values we need to add and multiply. Then we'll get the values of the regression coefficient. So let us see how we can apply in the problem by using this formula. For example, we can see that we are having some data set of values to fit a multiple linear regression model. We are having, this is the dependent variable, y is the dependent variable and x1 and x2 both are independent variables. We are having this data. So we need to find out the best fit line for this. So by using this dependent and independent variables, we need to first find out the mean values of the both data, dependent and independent. We need to calculate the dependent variable total mean value and the sum value also. First we need to find out the sum and next we need to do the average. And next for the x1 values also calculate the sum value and mean value. Same for the other independent variable, sum value and mean value. and we need to square those values x1 square and x2 square and x1 into y and x2 into y and x1 into x2. So like this we need to calculate all the data and get the sum of all the fields. So and we need to find out the regression sums like this by using the all calculations. And next we need to add those all values in the formula, and we need to find out first the independent variable values. For to find out the first independent variable values, b1 equal to summation, how many independent variables we have, those all we need to add and minus, and we need to apply this formula for all the summation values. Sigma x2 square and x1 square y and x1 into x2 and x2 y, all add these values for both independent variables of x1 and x2, and we got the answer of b1 equal to beta 1 equal to 3.148 and beta 2 equal to minus 1.656. So we need to add these values in the regression equation. Y minus y bar equal to x minus x bar. You need to add those values in the regression equation. Then we'll get the answers of all independent variables. Once you are calculating by using the formula, you got an answer of minus 6.867. So the estimated regression equation is y cap equal to minus b0 plus one independent variable 3.148 minus another independent variable value, we got minus 1.656, and we need to do the calculation for that. So now we can conclude that the first independent variables equal to minus 6.867 and another independent variable beta 1 equal to 3.148, another one is minus 1.656. So this independent beta 0 minus 6.867, this is the dependent variable. It indicates if the both predictor variables are equal to 0, then the mean value for y is minus 6.86. And for the independent variables, beta 1 equal to 3.148, 1 unit increases in x1 is associated with the 3.148 unit increase in y. So we can assume that independent variable x2 is held constant, and another independent variable values of minus 1.656, it indicates 1 unit increases in x1 and it is associated with the 1.6 unit decrease in y. So we can assume that other independent variable x1 is held constant. So like that we can calculate the data by following the regression equation. And now let us see in Excel how to calculate the regression equation by following the Excel formulas. And now we can see we are taking the same data from the previous PPT of details. This y is the patient value, patient numbers. This is the dependent variable, and x1 drug dosages and x2 blood pressures of the patients. This x1 and x2 both are independent variables for the dependent variable of patient. So now we are having plus 2 into 2 and so on. How many independent variables we have, that many we can add. So y equal to a plus that b1 into the first independent variable and b2 into other independent variable. So this b1, b2 and these a values, how we can get from this Excel, now we can see. First we need to go to file and we need to select the option, and there we can add-ins, click on add-ins, and when you click on add-ins, then the file it will show like this, manage Excel add-ins. So click on go. So you need to click on analysis tool pack, okay. Then when you click on data, there you can see data analysis tab. Click on the data analysis tab and you need to choose the regression and click on OK. And now you need to add the ranges. So input Y ranges are these. Y patient is the dependent variable and input X ranges independent variables, and we need to add that range, and we need the labels also. The labels means patient, drug dosages and blood pressures, and click on labels, and we need to choose the output range. And once you click on output range, in which place you want that data, click on that area and press this button and click on OK. And there here we can see the data of this what we need for to do that regression equation. Here we are having the summary output by following this table using the regression equation. The regression statistics multiple are the R value and R square, this multiple of R square value, and adjusted R square value and the standard error value, all regression statistics values, and the observations also. How many observations we have? 1, 2, 3, 4, 7, 8. All observations we have. So this is the data calculation. And next we are having the ANOVA table. In ANOVA table, we can see that degree of freedom values for the regression and the residual and the total values, degree of freedom values, these are, and the mean square values and the summation values and the F value and the significance of F values. So these all values we can get through in Excel. And this last table, the third table, here we can see the coefficients and the standard error values. So this table is very important for us, and there you can see the t stat and p values and the confidence levels of both lower and upper for 95% and upper 99%. All confidence levels also we have. So this table is very important for us now to calculate the regression equation and to predict the independent variables and for the dependent variables also. This table is very important. The intercept values also here we can see, and the independent variables of x1 and the independent variables of x2. So based on this data, we need to check the and we need to predict the upcoming information also we can predict. So if you want to choose for one dependent and one independent variable also, it's possible. For example, if you want to check for the dependent variable of patient and for the one independent variable to predict for the patients how many drug usages are happened, for that estimation also we can use the same procedure from the Excel. Again, we can go into data analysis tab and click on regression, and there we no need to change the Y range, and if you want you can change the X range. What is the independent variable you want? Suppose for example you want the drug usages only for the patient, and click on the data where you want the output. Click on the tab. Okay. And now again we'll see the regression equation, and don't change the Y range and change the X range if you want only one independent variable, and check the output range. And here we can see the output for the only for one independent variable, that is for the blood pressures with the same intercept values. So like this also, we can take how many independent variables you want. According to that, you can calculate and you can predict the data. So now we had the data of both independent variables and dependent variables coefficients and the standard errors and the confidence levels and the regression, the degree of freedom, all values, the summation values are here. So by using these coefficients values of the dependent variables, you can estimate and you can predict the value for the dependent variable of patient for the independent variable. For example, for 300 patients and with the blood pressure or for the drug usages, how for this number of patients, so the drug uses and blood pressures we need to estimate. For that we need to do the calculation. So we can do the calculation for the prediction, means we can estimate the value. Can estimate the value of, you can take the both independent variables, or else if you want only independent variable also we can take. For example, we can consider we are having 300 patients are coming tomorrow. So what are the drug usages might be 45 and the blood pressures may be 67, like that. Uh, if you take the ranges, and we need to get the information about the dependent variable of the patient. The drug usages might be 45 and the blood pressure may be 67. Then we need to estimate the dependent variable of patients. So for that we are having the formula that equal to the drug usages. We can take the drug usages coefficient values into the drug usage value plus and the blood pressure value into and the blood pressure value of the estimated patients, plus we need to take the intercept values also, we need to add the intercept values. Again we will see equal to the drug usage value into the estimated drug usage value plus the blood pressure coefficient into the blood pressure of the patient's values plus intercept value. And now we can estimate that 23 patients may, there is a estimation 23 for the 23 patients, the drug dosage and the blood pressure may be like this. So like this we can estimate by using these coefficients of independent variables and the intercept values. And the intercept values means, here we can see, so this is the x-axis and y-axis, and if it is a negative value means the x values are independent variables are increasing, the dependent variable is decreasing. So then we can say that y is a negative value and x is the positive value. And if the both sides the x and y values are increasing means that is the positive sign of the value. So we got the positive value in the problem. So now we can see that the patient estimation for this drug usage and blood pressure is positive. So and the same way we can see another example for the age of passengers and the duration in minutes and the distance in miles, and for the price estimation we are having the price is the dependent variable, and this distance in miles and the duration and the age of passenger, these three are independent variables. This is the dependent variable. So for this also we can calculate the regression equation by following the same procedure of this data analysis. Click on data analysis and go to regression and select the Y range. The Y range are from the D1 to D16, and the X range are all independent variables. Select the label button also, and the output range we need to choose where you want the data, and click on OK. So now we got the statistic regression values, multiple R square, adjusted R square values, and standard error value, and how many observations we have in the table. And next ANOVA table for the regression and the residual values of degree of freedom values, and the summation square values and the mean square values, and the F value and the significance of F value. So the significance of F value, we are having the positive value. And the third table we can see there for the coefficients of all the independent variables of age of passengers and duration in minutes and distance in miles. So these coefficients are very important for us to calculate and to predict the changes for the given data. And the standard error values, anti-stat p-values, and the confidence level values of lower and upper for the 95% values we have. So now we need to use this regression equation y equal to a plus b1 into 1 and plus b2 into other independent variables and so on. How many independent variables we have, that those all we need to add in that by using this data. So now again we can calculate and we can check the data based on this price. We can estimate the distance based on the price, the age of passengers, and the duration in minutes and miles also we can estimate, and by using the dependent variable of price. So you can select how many independent variables you want. You want all independent variables, means this all data we have. If you want only to check the duration in minutes and the age of a passenger or duration in miles also we can check. So we can check for particular independent variable values only. If you want to check, you can again select the data by following the same procedure of from the data analysis and choose the input X range only, means only independent variables only we need to select. And we can select the duration in minutes and distance in miles. If you want this independent variables only, you can choose the data wherever you want. So you need to select the place. So this data was copied here only if your tab is here. So again, if I want all independent variables data, again we can select the range of all this dependent variable data and the independent variable data, and click on the labels and the output range. We need to choose where you want and click on OK. Okay. And now So you can see the data will come like this for the only this particular independent variables, or if you want this many number of values also we can select and choose. And now we need to calculate the estimation for the values. Suppose for example, if we have taken the values of this, if you want to forecast for the duration in minutes and for the duration in miles, for this much duration of minutes and for this much duration of miles, we are going to calculate the price. So for that, we can use this regression equation formula, that equal to, for the duration in minutes coefficient value into the duration in minutes value plus the duration in miles coefficient, duration in miles coefficient into, and the duration in miles value plus the intercept values. And once you, when you click, the price range would be 59.98. So for this much minutes and for this many miles, we can estimate the price is 59.98. So not only for this data, we can predict the upcoming events, what may happen, by following this multiple regression equation. For not only this many passengers, for example, if we consider 100 passengers, if you choose 100 passengers, for the 100 passengers and for this many minutes and for this many miles. For example, we can consider the 60 miles and 60 for the 60 minutes and 7 miles. For the 60 minutes and for 7 miles, we can calculate the data, that equal to the minutes coefficient value, into, and the duration in minutes value plus, and the duration in miles into, duration in miles plus both intercept values. And now we can guess the price for this much duration, that will be 61.2. So the duration in minutes and the duration in miles for this much price of this independent variable, 61.2 for this much minutes and miles. So like that we can estimate the value by using this regression equation using Excel. Means we can predict and we can check the upcoming events for the same data of these dependent and independent variables. We can guess the information, what might be the price, what might be the this independent value variable related to these independent variables. So this multiple regression equation is useful to check the upcoming events, what may happen. For that we can predict. So we can predict that for this many minutes or this many miles, the price may be this much. And according to the table also, we can see for this much minutes and this many, for this much minutes and for this many miles, the price is this much. So like that, for the tomorrow upcoming events, we can predict and we can estimate, or else we can forecast the data by using this multiple regression equation. So like this we can calculate and we can follow by using the multiple regression equation. And for example, we can use this example also to calculate the regression equation. For example, we are having the two products, X1 and X2 products we have. and we need the dependent variable are sales for the product, for those two products. So we are having these many sales are happened for these two products. Product 1 we are having 1 and product 2 we have 4, but the weekly sales were happened only 1. So like this data we have. So for example, in next, if you are having um, 6 products of X1 and 8 products of X2, and what might be the sales by the week, by the end of the weekly sales, what might be the sales may happen. So for this we can predict by using this regression equation. So that the same procedure we can follow for the regression equation. When you go into data, click on data analysis and click on regression equation and select the range of y values and select the range of x values. Select the labels and click on output range and click where you want that summary output and click on OK. So we can see the regression statistics of multiple R square and adjusted R, standard error and observations, and the ANOVA table and the coefficient values what we need for to do the multiple regression, and the confidence levels also we can see. So the X1 product sales and X2 product sales coefficient values. So we got 3, and for the second product we got minus 0.05 coefficients. So now we can predict the future sale. We can forecast the changes in sales. So we can forecast of sales. So we can forecast the sales. For example, if you are having 6 products and 8 X2 product, and what might be the weekly sales for this. So again we can use the same equation, that equal to X1 the product coefficient into X1 product sale value plus and X2 product coefficient and X2 product plus the intercept values of the coefficients. And once you may click, we can estimate that the weekly sales might be 18. So the weekly sales might be 18. So like that we can estimate the product sellings or the duration of the passengers in minutes or miles. For for two or more variables, for the two or more variables of the independent variable, we can use like this equations to solve the problems through Excel or by following the equation of multiple regression equation also we can solve. So this is about the multiple regression equation problems solving by using formula and by using Excel.